Hey everybody, today we're going to be talking about linear versus nonlinear functions. I want to remind you that when you're watching these videos, please be taking notes in your notebook, hopefully that you have that with you, or on a piece of paper that you can keep track of, so it'll help you with IXLs and assessments in the future. So first off, just some definitions that we'd like for you to copy down. A linear function is a function whose graph is a straight line. Okay? A nonlinear function then would be anything that's not a straight line. So it's pretty simple, but write those down just so they kind of get lodged in your memory. The goal for today is to identify whether a function is linear from a graph, which will be easier, or an equation, which we'll show you both of those. Okay, so this should look familiar to you. What we have here is an equation, y equals 2x minus 5. Now, we've written y here in our input-output table, but we also could write f of x. Remember, those things are the same. So, you'll remember from practicing, hopefully, that when we have an input-output table and an equation, we take our first x value, we place it into the equation, and then we get our output value from that. So, if we take our first value, we would write y equals 2, and then instead of writing x again, we're going to write 3 minus 5. So all I've done here is I've substituted my first x value into my equation. And now I'm just going to simplify. So y equals 2 times 3 is 6 minus 5. Y equals 1. And so then I'm going to write 1 in my output column in my table. And then I'm just going to do this all over again for each one of my inputs. So y equals 2 times, now instead of 3, I'm writing 2. And I will continue to simplify. 4 minus 5. 4 minus 5 is negative 1. So I'll write negative 1 in my table there. Okay. Now I'm going to take y equals 2 times, instead of writing x, I'm going to put in my input, which is 1 minus 5. You'll notice the first step is always just rewriting the equation and substituting your input for x. 2 times 1 is 2. I bring down the minus 5. Continue to simplify. And y now equals negative 3. So I put negative 3 in my output column. The last one, y equals 2 times 0 minus 5. Y equals, well, anything times 0 is 0, minus 5. And 0 minus 5 is negative 5. So I'll put that into my output column. Okay, so now we're going to translate this. And remember, this is a linear example. So we're going to translate this and we're going to put it onto our graph. You see our coordinates here. We have the y-axis, which runs up and down. And then we have the x-axis, which runs left to right. And I'm going to just plot my points. So my first point is 3, 1. Okay, I took the 3 from my input, my 1 from my output. This is how we'd write it as an ordered pair. I'm going to go over 3 on the x-axis. I'm going to go up 1 on the y-axis. I'm going to put a dot. My next point would be 2, negative 1. So on the x-axis, I'll go over 2, and I'm going to go to negative 1 on the y-axis. My third point is 1, negative 3. I'll plot that. And my last point is 0, negative 5. And I'll plot that. Now look at what we've got here. I've got 4 points that correspond to the 4 points, or the 4 pairs of coordinates in my input-output table. And if I connect them, I am getting a straight line. And we said the definition of a linear function is a function whose graph is a straight line. Let's look at a non-example. So a non-example we have here is y equals x squared. And again, we could write f of x. So let's take my first input, y equals, Instead of writing x squared, I'm going to write 2 squared. And I always like to put my variable, when I put my number in, I like to put it in parentheses, and that'll be important here in 1 second. So y equals, now 2 squared, anything squared means you multiply it by itself. So 2 times 2 gives me 4. So I'm going to write 4 in my table there. Now my second input would be y equals 1 squared. 1 times 1 equals 1. We're going to do y equals 0 squared, which is just 0. 0 times 0. Now here's where it's important to use parentheses, because my input is negative 1. Y equals negative 1 squared. It's important to put this in parentheses because that negative sign is also being squared. We're not doing 1 times 1 and then making it negative. We're doing negative 1 times negative 1. A negative times a negative is always positive, and 1 times 1 is 1. So negative 1 squared gives me 1. We're going to do the same thing with negative 2. And we're going to put that in parentheses because we want to square negative 2. We don't want to square 2 and then make it negative. So we have negative 2 times negative 2. A negative times a negative makes it positive, and 2 times 2 gives me 4. So hopefully you've noticed this little pattern developing over here in our input-output table. Now I'm going to move our coordinates over here. And let's graph them. So our first one was 2, 4. I'm going to go over 2. I'm going to go up to 4 on my coordinate plane. My second coordinate was 1, 1. So I'm going to go over 1 on the x-axis, up 1 on the y-axis. 0, 0, that's very easy. That's called the origin. Negative 1, comma 1. So I go negative 1 on the x-axis and 1 on the y-axis. And then negative 2, comma 4. So I go negative 2 on the x-axis and 4 on the y. You'll notice those points, you cannot connect them to be a straight line. That's going to look like this, which is called a parabola, but we'll get there later. All you need to know for now is it's not linear. Okay? So make sure you have all those notes, and then we're going to summarize very quickly. So a linear equation, it will be an equation that has x with no exponent. Okay? That's very important. It can't have an exponent. A nonlinear equation, x has an exponent or a root, meaning like a square root or a cubed root, or is in the denominator, meaning the bottom of a fraction. So all of these would be examples of nonlinear functions. 5x squared, that's kind of like the example we saw. F of x equals the square root of 4x. F of x equals 3 over x. All of these are nonlinear. Make sure you have those notes. Pause and rewind if you need to, and we will see you again soon.